In this video a low voltage warning circuit, and I published it, at least the first circuit, say 1 or 2 years ago, and that was this circuit. It's a low voltage warning for a car battery, but I elaborated it somewhat the past days, and I made this circuit. And with this circuit you can say align a very precise voltage where you indicate that the voltage drops, say approximately 0.3 volts lower. And in the this is the circuit, by the way, and there are two LEDs. One is a green LED. That green LED tells us that you are, say, just above the critical voltage, and the red LED lights up when the voltage drops down 0.3 volts approximately, too much. But there is a big range here, the range, to which you can set that effect. And there are two Zener diodes. I will flip this circuit later in the video, so that's clear to see. There are two Zener diodes here, one of 6.2 volts and one of 3.9 volts. And they give different effects, and that means that you can set that effect in that switch on and off effect when the voltage gets too low or the current drops somewhat in a critical to a critical level. You can see these effects with the help of these two LEDs. The whole circuit obeys to Ohm's law, and the first good advice is don't use here a simple 10K potentiometer like I did here, but use a precision trimmer when you want to use this circuit in practice. And another advice is you have to, say, tweak the circuit to your own needs. And regarding Ohm's law, it is in fact very simple. We have here a resistor, and in the same lead we have the load. And there's a voltage drop parallel to this resistor, and there is a voltage drop in the load, and that load can be between, say, 156 ohms and 6 ohms. I've burned out that resistor almost anyway. So there's a voltage drop here and there's a voltage drop here, and the indication circuit works on the first voltage drop. And that also is one drawback of this circuit. You need a certain voltage drop to make it work, and that to make the LEDs light up. So there's minimal a voltage necessary of approximately, say, 8 volts or so. And that also means that it is not suitable for a circuit that takes a lot of current. That's also important. Well, at first a demo. This is the current that's flowing in the circuit. This is the voltage drop parallel to the load, that's here. And this is my power supply. Let's go to, say, 12 volts. Or somewhat more, 15 volts. You can see now that I've aligned the whole circuit to a situation where the green LED lights up, and I can tune that to a situation. And why you see kind of flickering, that's the reason why you need a precision trimmer. Anyway, you can set here with the potentiometer it to a certain voltage. Say now it's 14 volt supply voltage, and the load, parallel to the load, there is say 9 volts. And when the current is approximately 50 milliampere. And when the voltage drops to a critical level, now I change the voltage supply, the value here of the voltage supply, and in practice that is a voltage supply, and the load is, for instance, an electronic circuit. When that electronic circuit gets a too low voltage, suddenly the red LED lights up. And when the voltage goes up again, and you need for this application bright types of LEDs. That's very important. So now in the dark I change the supply voltage somewhat, say 0.3 of a volt, and you can see that the red light starts to light up. By the way, the green LED also lights up somewhat anyway. So it's a kind of indication, coarse indication. By the way, there are more better circuits that can do this, say voltage indication, and for especially for current indication there are surely better circuits with op amps or so. But anyway, you can also use this for say as a current indicator, but the current relies in this setup also on the voltage. Ohm's law is valid, and that means that we have a, say, tiny change in current here where the circuit reacts. Perhaps I can show it this way. This is far too much, the distance I mean to the amperemeter, but anyway, we go to the amperemeter, close, 11.1 volts. That's too low voltage. Now the LED is red. I raise it somewhat, and now the LED is green. So the difference between these two readings is not very big. Green, red. So say it's a difference of say 10 milliampere or so. Could be important when you need such a, say, indication that there is a slight change in the current, but it's more or less simple, say, low voltage warning circuit or different voltage warning circuit. Anyway, that was more or less all to tell. I want to flip the circuit so that it's possible to see the schematic in a better way. And again, all acts according to Ohm's law. Voltage drop here, current flowing in the circuit. That means also that the circuit will act in another way when, for instance, this resistor is smaller. So you can use it for situations where there is a higher current, but at the same time there must always be a voltage drop of, say, approximately 8 volts here. Otherwise the circuit doesn't want to work. That's important. The transistors are all PC547B. The load is now say 180 ohms, but can also be smaller, say 6 ohms, and that is everything to do with the circuit in which you want to use this, say low voltage indicator or critical current indicator. And always fun to see LEDs switch on and off. So, well, I hope it was a little bit clear. Thanks for watching. These are, by the way, the ranges in which the circuit can work. And then, say the voltage where it switches is approximately 0.3 volts. And the way that the switching process works is that I've made here, say, a kind of variable voltage drop. You can change that voltage drop in a very tiny way with the help of that potentiometer. And that makes that you can set the zener to a certain critical value. And in this case, when you want to make the first circuit, I found that this potentiometer sometimes is not able to set the whole circuit to a good switch moment. Anyway, it's so simple. And I've also tested this circuit, and that also really worked. That's always important.